Good morning, everybody.
Good morning, Professor.
Hey, good morning, Kara Liz. How's everybody else? I just, hear the response from Kara Liz only. Only one person graded back. What happened to the other people?
Good morning, Professor.
Hey, good
Good
morning,
morning, Professor.
Corey. Good morning, Angelica. Um, it's happy Thursday, right? Bright and shining. Um, I see 10 people in the collaborate, and I let me quickly check how many people are there in the. I see 11. So still one more person. One more person needs to join the collaborate. That's fine. I'm hoping that person will join us uh, shortly. Now, I was So in our last class, let me just pull up a couple of files uh, before we continue. Where is the file that I'm looking for? Okay, I'm gonna have to open up. Okay, it's gonna be opening shortly, and let me make sure I have. All right. So in our last class, the last thing we talked about was basically the reverse relationship between the future value and the present value, right? In other words, you should be familiar. Why isn't it? The compounding formula, right? Oops, this pen is not. Okay, I'll have to write it somewhere. Something's not right with this pen. Okay, it's not working. So we know that the future value, the compounding formula, which we arrived at, right, through the steps of derivation. Of course, you might think, don't we need to memorize only this formula? Yes, I mean, if you want to memorize it, yes, this is, all you need. But again, what you saw in the last class is this is only the final result, final outcome, right? But the process, what you saw last time, it's the process to arrive at this final outcome. Okay, so the process is more important actually than the final outcome because it's easy to memorize the final outcome. It's not a difficult thing. But then being able to logically deduce how we arrived at that final outcome, that's more important because that's what makes your brain uh, uh, rise above, right? That's what makes your brain um, push the envelope of your intellectual capacity. That's what then, a whole process of analytical reasoning and logical reasoning, that's what makes your brain, in other words, um, you are filling in the gap that existed between the final outcome and the inputs. You understand what's happening, inside between the input and the final output, right? What's the process that's taking place, right? So that's why I spent that much time just to explain how we arrived at, this generalized result. Okay. Now then, I said also in the last time, uh, compounding formula is basically what we need to solve for the future value. In other words, future value is the unknown. That means everything else is known. In other words, there are 4 variables here, right? And those 4 variables are, we already know, it's, future value, principal, R, and N. These are all variables, and sometimes this can be the unknown, but sometimes this can be the unknown. Sometimes this can be the unknown. Sometimes this can be the unknown, right? All right. I think I will have to. What do I need to do? Maybe pull it up. So give me some. I want to write it really neatly. This is not neat. So it's P times 1 plus R raised to N. Okay, it's not neat, but that's the best I can. Maybe, let me try this. No, it doesn't. All right, and then our next question is, so in other words, in future value, right? In other words, in compounding, future value is the unknown. Principal is known, right? Everything else is known. Principal is known, right? R is known, N is known. For example, let's say we used, oh God. All right, maybe I'll just lean the computer over the wall and maybe there's more support there. So basically, P is 10K, right? I mean, in our example, our rate is 10%, time 10 years, right? So these things are known. And we calculated the result. It's almost, then, the future value is almost 26K. But, if P is the unknown, what if what if the P is the unknown? That means, then if P is the unknown, why is there so much jitter? And why something like this here? If P, if P is the unknown, that means future value is known. Of course, in our scenario, future value will be almost 26K, right? So we would know what P is because we started with the scenario where the original principal is 10K, and based on that input, right? 10K and 10% and 10 years, we arrived at this future value of 26K, right? So obviously then, based on that initial scenario, then the principal must be 10K. But let's think about how this can be done mathematically. In other words, how do we solve for P when P is the unknown? Now, think about it. I say this in every class, every semester, every year, which is the key to solving any equation. Key to solving any equation is to discover z equals x times y structure, or z equals x times y format. Why? Well, think about it. Then let's say x is the unknown. If x is the unknown, right, then all you need to do, first of all, if x is the unknown, right, basically, when you have z equals x times y structure, z is the unknown, isn't it right? So z is the result of x times y, right? That's what z equals x times y structure is telling you. But then if x is the unknown, then how do you solve for x? Of course, then it's z divided by y. Isn't that right? Then x is z divided by y. And if y is the unknown, it's the same thing. Y will be z divided by y. Y will be z divided by x. Okay? It's basically the same thing as 12 is 3 times 4, isn't that right? And then what is 3? How do you find 3? It's 12 divided by 4. How do you find 4? It's 12 divided by, right, 3. And think about it. We find the structure there, isn't it right? In other words, f equals p times 1 plus r raised to n. That's exactly z equals x times y structure. Some people might say, how? Well, this is multiplication, right? This is multiplying, right? P times is exactly the same structure, right? Think about it. Fv is z, right? P is like x, right? And 1 plus r raised to n is y. And if some of you may not realize that 1 plus r raised to n is just one term. It's just one single term, right? Because anything, think about it. 2 raised to the third power. This is just one single number, isn't it right? It's not two different numbers. Isn't it right? Everyone understands that, right? So, okay, we have exactly the same structure. We have the same structure. Then, what we don't know is P, so what do? Oh, well, we will have to divide FV by, right? So then what we need to do is, then P equals, right? We'll have to divide FB by 1 plus R raised to the N. Okay? Now, if you think about it, I want to put a perfect circle there. Okay. If you think about it, in our example, this is like 10 years later, you'll have about 26K. So if you discount it by 1.1 raised to the 10th power, then you'll get to 10K, which is the principal. In other words, it's the same story. It's just reverse process. I mean, you'll need to put in 10K today to arrive at the future value of 26K 10 years from now at 10% interest rate. Okay? In other words, what should be the principal? When you don't know, let's say you want to have 26K 10 years from now, and currently the market interest rate is 10%, then what must be the principal? In other words, how much money do you have to put into the bank today, right, to reach 26K 10 years from now? So it's simply, by solving this equation for P, right, the same equation, by solving the same equation for P, because P is the unknown, then you can reverse engineer. In other words, you understand what reverse engineering is, right? You're trying to it's basically inductive method, right? As opposed to the deductive method, right? From you have the outcome already. What is a good example of reverse engineering? I mean, they say a lot of modern technology originated from alien technology. When in 1940 something, 48, when the alien craft crashed at Roswell, Texas, in 1951, I guess. And then of course, the military and the government, CIA, and everybody covered up. They say, they at first, the media released the news that it was a spacecraft, flying saucer. That's what they called it at the time, flying saucer. And then all the media was covered up. Media reports were covered up by the military and the CIA, and saying instead it was later discovered it was weather balloon, and that's and still a lot of controversies are around it, and they say, of course, if they think, I mean, weather balloon. Think about it. In the crash site, what was first discovered were some metal pieces, right? Obviously, if it is a spacecraft, uh, it would be made of, some metal, right? And then suddenly, weather balloon and has no metal part, right? Weather balloon doesn't have metal surface, and so obviously it doesn't corroborate, right? That story doesn't corroborate. In other words, the cover up doesn't corroborate. I mean, how can anybody mistake the piece of cloth and plastic, or rubber, or a piece of pieces of shattered pieces of weather balloon, which would be mostly like plastic, or cloth, made of plastic and cloth. Who How can anybody confuse that with the metal, sheet metal? I mean, aluminum foil type of metal. But anyway, then they studied. And also, World War Nazi Germany had, there's all this controversy that during World War II, Nazi Germany had access to alien spaceship, or crashed alien aircraft. So that's why they could come up with, but towards the end of the World War II, they could come up with a lot of advanced weaponry, especially advanced, aircraft. But it was too late. They were the first ones to come up with the jet fighters, but it was too late. Too late to turn the tide of the. And they had a lot of aircraft designs that are out of that time, out of that era, right? Even in those days, they had the experimental aircrafts that looks like B-2 bombers, right? Well, B-2 bomber looks pretty much like triangular shape. So how could they be had such an advanced design in aircraft? It's because they were able to somehow they got a handle on some crashed alien craft. So in other words, figuring out from that crashed spacecraft, figuring out how it was built, that's reverse engineering. And just like that, this is reverse engineering from from this original outcome, right? Because in the original outcome, the original formula, which is compounding formula, is basically how you arrive at the future value, right? Future value is the solution, but you reverse process, basically. Reverse engineering is not the word, through the reverse process, you arrive at the principle and figure out what the what should be the. So without further ado, now you got the idea. Let's do some. I've always told you, let's do some hands-on Excel exercise, right? Now, in every topic folder, there are some files that go with the video, and there's an instruction to download, right? It says, please download the above files. So you must download these files. Now, you must have downloaded these files already. And as the main lecturer, you must have, you should have watched all these main lectures all this time. which is already, we are done with that already. We're actually into a bond valuation already. Today's topic is, I believe, bond valuation. We're already into topic 4, right? And it's not just, it's not the first time. Since this Tuesday, we've been into topic 4 because today's main lecture is bond valuation part 3. So that means on Tuesday, you had, bond valuation 1 and 2. That's the main lecture. Once again, collaborate is not the main lecture. Don't depend on collaborate. Collaborate is always just the review, right? So as you were following the main lecture, then you should have all downloaded these files. Of course, this is the PDF file. This is obvious. It's Excel file, right? If you download this, and I want you to open this file in front of you. If you have already downloaded, you can just open the file. If you haven't, download it now. If you download it, it will be, look, I want you to have this in front of you. And there are many bottom tabs. You see there are multiple bottom tabs. And it may be this one when you open it, but it should you should come to the first bottom tab, right? Because there are multiple worksheets, right? You should come to the first bottom tab that says single cash flow. And if you're there, please delete all the highlighted cells. Please delete all the highlighted cells, okay? Delete all the highlighted cells. So first, let's do this. Let's think about it. Does everyone have this opened in front of you? Everyone? Let me check. Angelica.
Yes.
Yeah, do you have this file opened in front of you?
Yes.
Okay, great. And then Jeremiah. Jodian, your microphone is on. So Jodian, do you have this file opened in front of you?
I do, yes.
Okay, great. Jeremiah, are you there? Jeremiah?
Yes.
Okay, good. Do you have this file in front of you?
Yes.
Okay, great. How about you, Kathleen? Kathleen, do you have this file in front of you? Kathleen?
Yes, I do.
Okay, great. Maricel, do you have
Yes,
this
Professor.
file in front of you?
Yes,
All right,
Professor.
great. Good. Nicole.
Yeah, I have the file up.
Okay, great. Nickery, do you have this file in front of you, Nickery?
Yes, I do.
Great. I didn't even see your microphone icon, but you are. Okay. Noel,
Yeah, I have it up.
do you have this file in front of you?
Yeah, I
Great.
have it up.
Okay, great. Vivian, do you have this file in front of you?
Yes.
Okay, great. Now, so as I said, you need to delete all the highlighted cells and make sure your your input data matches mine. Does your input data match mine? And this is our example exactly because principal is 10K, APR, which is annual percentage rate, 10% time 10 years. Okay, and for now, ignore column D. Okay, so let's find the future value. We're doing exactly like this. I mean, exactly what the formula is. Future value is equal to P. Okay, principal is in A2, so you just click the data in, right? You don't have to type that in. You can just click it in with the mouse, right? Just select this and then just click the mouse and it's going to go in, okay? And then times, that you will have to type in, right? Because there's no way you can do that with the mouse. You can click in the data, but these operators, you'll have to type it in. there's there's that asterisk on your keyboard, right? So you just need to type it in, and then open parenthesis. You need to do that also. Then one also plus 10%. Okay, then close parenthesis, and raising to power. You raise it to power. This symbol is universal machine language for raising something to power. Okay, so you have to enter it, and then 10 years. Also click it in and hit enter. Okay, so now we got the our future value, which we calculated with the calculator, right? We got that using the calculator in the previous class. Now, so nothing special, nothing unusual here. But here, next, let's look into this column D. What is that M? The label is M. M is compounding frequency per year. Compounding frequency per year. So that means, per year, how many times the compoundings happen. So if it is 1, it's annual compounding because it's once a year. If it is 4, it's quarterly compounding. In other words, compounding doesn't have to be just once a year. It can happen quarterly or monthly. If it happens quarterly, it's 4 times a year, isn't that right? 4 times a year. So compounding frequency is 4. 2 means twice a year. So that means semi-annual, right? Semi-annual or semi-annual. 6 months, every 6 months, right? So some people confuse it with 6. I mean, if it happens if it is semi-annual, it happens 2 times a year, not 6 times, right? So it will be a gross mistake if you enter 6 there, because if you enter 6 there, that means it happens 6 times a year. That means every 2 months, bi-monthly. Now, theoretically, there's no reason it isn't possible. Theoretically, it's possible, but they don't use bi-monthly compounding. If it happens 12 times a year, it's monthly, of course, right? Theoretically, it can be daily, 365 days. And in reality, they use even daily compounding, up to daily compounding, but they don't use anything below. I mean, theoretically, it can be by the hour or by the minute, by the second, or even by nanosecond. Theoretically, it is possible, but realistically, they don't for all practical reasons, they don't use any compounding frequency above or below daily. Okay, and then if compounding is 4 times a year, quarterly, right? Then each time the rate, what will be the interest rate that will apply each time? If compounding is quarterly. Now think about it. Our annual interest rate is 10%. So if compounding happens quarterly, every quarter, what should be the interest rate that applies?
2.5.
2.5, yes. And who said that?
Jodianne.
Okay, Jodianne. Yes. You got 0.25, right? You got 0.25 for that. Yes, of course. It's 10 divided by 4, right? 10% divided by 4. Now, so how do we incorporate that into our formula? Well, we can do it this way. We will adjust APR by M and also adjust the time by M. Because if the time is 10 years and compounding is quarterly, there will be 40 compoundings over 10 years. So all we need to do is then, I'm not going to do it here. I'll do it here. You might wonder, that's just annual compounding. Why would you do it there? Just, bear with me. So I'll think about it. I'll divide 10% B2 by D2. Of course, nothing will change because it's 1. You're dividing something by 1. Nothing will change. And here, I will need to use parentheses. And I'll need to times it by 1. I'll need to multiply it by 1. But parenthesis is necessary. Why? If you don't do that, this term will be raised to C2, and the result of that will be multiplied by 2. So in other words, PEMDAS, right? It's a very basic rule, but people sometimes forget a lot. There were on Facebook there was this question about what is I mean there were this was really the a simple question of PEMDAS. But then people a lot of people get that wrong. So to avoid the whole thing get raised to C2 and then the result of that being multiplied by D2, to avoid that, we will need to put this in the parentheses. And of course, nothing will change because it's just 1, right? Nothing will change. It's still the same. But then this can be simply copied and dragged and copied down. Dragged and copied. The formula can be dragged and copied, right? Okay. That way, it will automatically be taken care of, right? Because it's the a lot of students think a lot of students really don't appreciate Excel enough because they think it's just a bunch of numbers. No, numbers are only the surface. Numbers are what's on the surface, right? What's in the cell is not really the number, but the formula, right? And the result of the formula is only reflected on the surface. So what's being copied is the formula, not the number. Okay? Now, this will make our life a lot easier. This will make our life, when we have, think about it, I have only 2 problems like this in the first example. But if I had 100 problems like this, problems of the same pattern, right? And with the input data already, filled in, then what do I don't have to do it all over again. Usually, when you use a calculator, you have to input the data all over again and, solve the problem all over again. But once you use Excel, the problems of the same pattern doesn't take separate calculations. You don't have to do it again. You can just simply copy and paste all the way down. Okay, so that will make us that will take us to the next example, and the next example is it's pretty much the same thing, but then with different input and different compounding frequencies. So here I have 2 additional columns, which is the column for R and the column for N. What is R? We know it is rate, but then how is it different from APR? APR is the annual percentage rate, and I've been telling you all the rates must be expressed as annual, right? Basically, so all interest rates are expressed as annual, right? They are all, but then you remember if compounding is quarterly, the actual rate that gets compounded every time is 2.5%. So what is this called? This is called the periodic rate. Okay, the periodic rate literally means, the rate that actually applies each compounding period. Okay, then n is the number of actual number of compoundings, right? We used to call it t, and t represented t was usually years, but since the compounding doesn't have to be annual, right? Actual compounding maybe like in this case, remember in our quarterly example, right? It's actually 40 quarters. Over 10 years is 40 quarters. So if we, instead of doing this, instead of making adjustment inside the formula, right? What I'm trying to do is, instead of making adjustment inside a formula, I made adjustment outside the formula. I made adjustment to two of the input data, and then I used just simply the simpler formula. I simply do A6 times, right? And I want you to do this all together. I mean, as I'm doing this, you shouldn't be just watching it, but you should also be doing it. That's why I told you to clear out or delete all the highlighted cells. So future value equals A6 times 1 plus R raised to n. Okay, same result, but this way, it's a lot, the formula gets a lot simpler, and the simpler it is, it will be easier to fix if something goes wrong. If the formula gets more complicated, it's going to be more difficult to fix because it's going to take more time. It's going to be more difficult to identify the source of the problem. Okay, but if the formula or the mechanism is simpler, then it's easier to identify the source of the problem, right? It's easier to detect what's wrong, what went wrong, right? If the mechanism is more complex, it becomes more difficult to detect the source of the problem. So here, this way, if the source of the problem was already outside the mechanism or outside the formula, it's easier to even easier to detect. Oh, if something went wrong here, oh, I can tell. Oh, I was, I did like this, or you can easily detect what went wrong. And then once you've done it like that, all you need to do is you can highlight these all three rows, all three cells all together, and you bring the cursor to this corner, and the cursor turns to a thin black cross. And I explained this to you. I showed you this in the first topic, right? Remember, the first topic was house value, right? ROI, and in that topic I used house value example, and I showed you in that how to copy and drag, right, to paste, all the way down. So if you drag it down, look, all these problems, how many problems? Like, 6 problems, just done in a second, okay? And also, some people, it's 11:50 already. Some people ask me, so Professor, why don't we use, Excel's built-in function? We can use that, but I would say no. I don't want you to use that. Why? Because we can use, for example, a future value, right? We can use future value, but then, all you do is you give, rate, right? All you do is simply, entering input data. right? And then you have to enter even the present. In a financial calculator, you have to enter, you get the same result, but what you're doing is nothing but it's turning you into nothing but someone who inputs the data. In other words, you're just doing the data entry. You understand? You're just punching in the data. That's all you do. Without knowing what's going on you're just punching in the data into a black box, right? Without knowing what's going on in the black box, right? So you have no control over it. That's why I don't like Apple computer. I'm an Apple shareholder, but I don't like the way the Apple computer is built because you can't fix it. You can't upgrade it. You can't do nothing about it. You have no control over Apple computer. If something goes wrong, you have to take it to Apple store to get it fixed. But IBM computers, I can upgrade it. I can fix it. If something goes, there's something I can do, and I know what's going on, right? I don't know completely. I don't understand the computer's mechanism or the system, how the system works completely, but at least I know to some extent. I can learn and I can understand to some extent. But Apple, you can't tell. You can't, you can't upgrade it, you can't fix it. So in other words, you are only a captive consumer, right? You're only a captive consumer. It's just like that. If you use Excel's built-in function, you're just a data entry personnel. You don't have any control over the mechanism, right? And besides, think about it. What would you do? What would you do if, in this case, compounding frequency is 4? Then what you will need to make adjustment. Again, that's also the rate. So you will need to enter as rate B3 over D3, and then for n periods, you will have to enter C3 times D3. And always the cash, you have to make distinction between cash outflow and cash inflow. Think about it. You make a deposit of 10K today, it's a cash outflow. So it has to be negative to have a positive input cash inflow in the future. So you have to make these adjustments anyway to the input data, right? Then, you'll have, but then think about it. You have no control. You're just, data entry personnel. But here you have control over that mechanism. What's important is being able to understand the mechanism and being able to have control over the mechanism. Right? That's what's important. So then if something goes wrong, you can fix it. But if you're just punching in the data into the black box, if something goes wrong with the black box, you can't fix it because you don't know the mechanism. Right? That's the reason why I don't want you to use Excel's built-in function. Some of you may be already familiar with Excel's built-in function. But then, a lot of students go wrong with it because they don't know, they don't think about, they never thought about, adjusting the input data according to the different context of the problem. Or, they don't, or either that, or they don't quite figure out which one is the input, which must be used as an input, or which must be, input X, input Z, input W. Some students don't are not able to distinguish between those different inputs, and then they all mess up. They all end up with the wrong answer because they think Excel will be infallible. So, but they don't know. They don't get to think that they have to understand the context where different inputs must be adjusted for the context, right? And without any and they don't have any understanding of the mechanism. Anyway, so we're out of time. Almost 7 minutes past our, So I'm gonna have to stop here today. If you have any, so we're already, behind the schedule. So if you have any questions, you can, use my office hour or send me an email. And I just want to remind you that there is a midterm starting this Friday, which is tomorrow. Okay. All righty. I'll see you guys. Have a great weekend. Don't forget about the midterm, and I will see you guys next Tuesday. All right.
Thank
All
you,
righty.
Professor. See you next week.
All right.
Next weekend.
Goodbye, Jodianne. Goodbye, Angelica. Take care, everyone. Stop sharing.